In this video, we're going to look at properties of a graph of a quadratic function. In 1, it says, in module 79, we found that y is equal to x squared minus 6x plus 5 can be written in the form y is equal to x minus 3 squared minus 4 by completing the square. Using transformations of the parent graph y is equal to x squared, we obtain that the graph of y is equal to x minus 3 squared minus 4. In module 78, we found the x-intercepts to be 1, 0 and 5, 0, and the y-intercept to be 0, 5. Graphing the intercepts in addition to the transformations provide a more accurate sketch of the graph of y is equal to x minus 3 squared minus 4. So the first thing we're going to do is look at the parent graph. And in the parent graph, you can see that our vertex is at 0, 0. And our x and y intercept is 0, 0. And now looking at the graph of y is equal to x minus 3 squared minus 4, we can see that our vertex is 3, negative 4. And then we're also going to look at our x-intercepts, which we found to be 1, 0 and 5, 0. And then we found our y-intercept to be 0, 5. And now we're going to look at the follow-up questions to the graphs. So in A, they ask, what are the coordinates of the low point of the graph, i.e. the vertex? So since our parabola is opening up, we have a minimum point or a low point, and that's at the vertex, 3, negative 4. And then it asks, how do these coordinates relate to the equation y is equal to x minus 3 squared minus 4? And if we were in vertex form, and go ahead and give a reminder of vertex form, we have y is equal to a times x minus h squared plus k. Our vertex is h k. And here we have h represented by 3 and k represented by negative 4. So that's how we got our vertex of 3, negative 4. In B, it asks, what is the equation of the vertical line that divides the graph symmetrically? And our axis of symmetry is going to be a vertical line that goes through the vertex. So it's going to be the line x is equal to 3. And C, they ask, what is the minimum value of the function? And the minimum value is the lowest y value that the function takes on. And we can see that that's at the vertex, negative 4. And then it asks, what is the range of the function? And the range of the function is all the y values that the function takes on. And if negative 4 is the smallest value, we're going to have from negative 4 to infinity. And it asks, how do these relate? And we can say that the minimum value is used as an endpoint of the range. In D, they ask, how do the answers in parts B and C relate to the answer to the coordinates of the vertex? And if we look at the vertex, 3, negative 4, we can see that 3, the x-coordinate of our vertex, is the axis of symmetry. Which we found to be x is equal to 3. And our y-coordinate of our vertex was the minimum value of the function, which we found to be negative 4. So our range was negative 4 to infinity. And that's all for the properties of the graph of a quadratic function.